Hey everyone, so this is lesson 2 from unit 5 and we're continuing with stoichiometry and moles. And by the end of this lesson you will be able to determine the percent composition of compounds using the formula that is given to you on the reference tables. So we're going to delve into some more of those formulas on that last page there. So as a warm-up, on page 2 of your note packets, the next section, you're going to put in the date, which today is January 5th, the day I'm recording this lesson. Hopefully you will be putting January 6th for the night that you are watching this. And I want you to answer this question. So you're going to pause the video, look up the answer to this question, and then put your answer in the box to the right. So the question is, what is the difference between the formula mass and the gram formula mass of a molecule or a compound? So what you're going to do is you will have to go back to the previous lesson, maybe to help you answer this, or you can look up the words on your internet. So once you have your answer, I want you to check and see if you're close. The formula mass is the mass of all of the parts of a molecule or a compound in AMUs. Okay, the GFM, or the gram formula mass, is the mass of a molecule or compound in grams and represents the mass in 1 mole of that substance. So that's the difference between formula mass and then gram formula mass. All right, so let's start with our notes. Page 4 in your notes, calculating percent composition. Step 1, first we have to calculate the GFM for the compound or the formula mass. So for example, we have calcium chloride, CaCl2. Calcium, there's one of those, and we look up the formula, or the mass on our periodic tables, and we see that it's 40.0. So the total here is going to be 40.08. And we could say grams here if they're asking for GFM. Okay, and then 2 times 35.453, so take a minute to calculate that. Okay, so you should have 70.906 grams for the part of the compound that makes up, or the part of the chlorine that makes up the compound. When we add these up, our total is 110.986. Okay, so that's the total mass, or the GFM, for the entire compound. Now remember, when we're going to round this, we have to round to the least number of decimal places because we're adding. So there's 2 decimal places here for sig figs. Okay, so our answer will be rounded to the hundredths place here. So it actually would be 110.99 when we use that in our final answer. So we will put 110.99 grams. Okay, sig figs. Step 2, okay, so now we have the GFM and we have the parts. Okay, so it says to check the last page of your periodic table for the formula for percent composition. We're going to write the formula. Percent composition by mass is the mass of the part. So that would be any part that they're asking for in the question, either calcium or chlorine, divided by the mass of the whole, which then would be this number here, okay, and then multiply by 100 to get percent. Remember, percent is out of 100. So we're going to use this formula to calculate the percent composition of each element or part in our compound to the nearest tenth. So let's do that now, and we're going to go back up here because I'll use this right in front of us. So the calcium part is 40.08 grams out of the entire mass, which is 110.99 grams. Okay, and we're going to multiply that by 100. That will give us the percentage for the calcium. Okay, and then I'll set it up over here for chlorine, and I'll give you a minute while you should pause the video to do your calculations, and we'll double check to make sure that we are together on the same page. So for chlorine, the mass of this part is 70.906. Then we're going to divide that by 110.99. Okay, grams, okay, times 100. So pause the video, do your calculations, and then we'll get back to checking that. Okay, so you should get 36.1% for the calcium, and 63.9% for the chlorine. So when we add up the percentages, they do add up to 100, and we know we are correct then. All right, so remember this part though. The answers or the percentages would be to the nearest 1/10 of a percent. So when I rounded my answers, I made sure that my percentages were to the nearest 1/10. Okay, very important. Next, so now we have to practice this. Really, I gave you a general example, so bring this into practice. We're going to use the same formula. It says, what is the percentage by mass of carbon? So we're just dealing with this part. So first we have to look up the atomic mass of carbon and the atomic masses of the oxygens. Okay, so there's 2 of these. There's only 1 of these. And I will give you a minute to look at that. So pause the video, look up those atomic masses. Okay, so I'm going to use my values from before. And let's just fix that pen there. Sorry, guys. 12.0107. And then 2 times 15.9994. And we're going to add those up. $31.9988. So when we add those, let's say to ourselves, okay, so there's 4 decimal places in both, so the answer has to be rounded to 4 decimal places, and this is going to be 44.0095 for the GFM. Okay, so that's for the whole thing in grams. They want to know what is the percentage by mass. So it doesn't matter if it's in AMUs or grams because you're going to end up with a percentage in the end anyway. So we're going to say that the mass of the part of the carbon, so this is what they want to know. Okay, so this is the mass of the part divided by the mass of the whole, which is this, 44.0095 times 100 is going to give us 27.3%. Remember, 10th place. Okay? All right, number 2, what is the percentage by mass of nitrogen? So we're talking about the nitrogens here in NH4NO3. This is ammonium nitrate. Okay, if you remember how to name ionic compounds, these are 2 polyatomic ions. They're both listed on your polyatomic ion chart. All right, so we have to figure out nitrogens, hydrogens, and oxygens. And then we're going to figure out the GFM and then figure out the part. So this is the part that we want to know. So let's figure this out. We have 2 nitrogens, so it's going to be 2 times 14.0067. That's the atomic mass, don't forget. Hydrogens, looks like there's 4 of those, so we're going to go 4 times 1.007994, excuse me. And oxygens, we have 3, so we're going to say 3 times 15.9994. Okay, pause the video, take a second to do your calculations, and we'll reconvene in a second. Okay, so once we do all of our calculations, our gram formula mass is going to be 80.0434. And when we figure out the mass of the nitrogen out of the entire formula, we get 28.0134. Divide that by the total, 80.0434. Multiply that by 100, and we get our 35.0%. Your calculator probably will say 34.99776, but remember, if we round that to the nearest 10th, that's going to bump this number up to 35.0. Okay, so number 3, what is the percent by mass of oxygen in magnesium oxide? So they give us the name, we have to write the formula. This is why we did this unit previously. Okay, magnesium has a +2, oxygen has a -2, so the formula is going to be MgO. Now we have to get the atomic mass of magnesium, the atomic mass of oxygen, because there's only 1 of each. So this is going to be a little easier. Magnesium is 24.305. Oxygen, again, is 15.9994. And we're going to add these up. 3 decimal places. So we're going to get 24 point, I'm doing this with you guys, so bear with me here. Okay, and you're going to get 40.3044, but remember 3 decimal places, so we're going to round here. We're going to say 40.304. Okay, grams or AMUs if you're doing formula mass. Okay, now we want to know the percent by mass of oxygen. So we're going to do the mass of the part, 15.9994, divided by the mass of the whole, which is 40.304, times 100. Remember, to the nearest tenth, so we're going to get 39.7% oxygen in magnesium oxide. Okay, so the other percentage would be the magnesium. It's based on the mass of the entire formula. Next, okay, so we've seen these before in the last unit. I told you we would delve into it a little more this unit. Okay, so the special type of percentage composition would be for hydrates. Hydrates are crystalline structures. So hydrate is a crystalline compound in which ions are attached to one or more water molecules. So here's an example. We've seen these. Okay, this little dot means incorporation or part of the compound but not actually absorbed into it, becomes a crystal. So we have sodium carbonate, and this is going to be decahydrate because there's 10 deca. So notice how water molecules are built into the chemical formula. Substances without water will then be called anhydrates. Anything without the water built into the formula. So if it said this, Na2CO3 plus H2O, okay, this is an anhydrate because we're adding water to it. It's not actually built into the formula. All right, so let's figure out what the percentage by mass of just the water in these sodium carbonate crystals. So what we're going to do is we're going to calculate the formula mass for the hydrate, and we could do water separately as it is part of the formula, but we're just figuring out water itself, not any part of water. Okay, so that's why down here you notice that water is completely separate. There's 10 of those. So water is always going to be 18.0153. Okay, AMUs or grams, they said formula mass. So this is going to be in AMUs. Okay, oxygen, again, 3 times 15.9994. Carbon is 12.0107. And we have 2 sodiums, which we have to look up, which is 22.98977. All right, so I'm going to give you a minute, calculate this, and we'll check back. Okay, so once we do all of our calculations, we should get 286.141 AMUs. I rounded to the 3rd decimal place because that would be the number of, or the least number of decimal places that we have when we add these numbers up, okay? So it's going back to sig figs. All right, so next step now, we want to know the percentage of the water. So we have to go back to that formula and figure out, okay, so here's our total mass of our water, and this is the mass of the entire formula. Okay, so then we use this same formula here. Percent of water is 180.153 AMUs, and the total is 286.141 AMUs times 100. Remember, units don't really matter here. We're going to end up with the percentage anyway. So let's plug that into our calculators here, and we will get, remember, nearest tenth. So this is going to be, sorry, 63.0%. Okay? All right, so hopefully you guys are getting a hang of this now. Basically, we're just figuring out percentages. So let's do a couple more practice questions, and we're going to be done. So what is the percent by mass of water in barium chloride dihydrate? So where I get the names from, I'm looking at how many water molecules we have. So we have to figure out barium, okay, 1 times the mass of that, and we have 2 chlorines. Okay, so we have to look up the mass of those, and we have water, 2 of those, and I said the water is always going to be 18.0153. We'll do grams, it says percent by mass. Okay, so once we're finished with all the calculations here, and we look up the masses on our reference tables and the periodic tables, barium 137.327, there's only 1 of those. Chlorines, there's 2, so multiply that, the atomic mass by 2, so you get 70.9054. Water, again, the entire mass of water, since we're going to count that as 1 unit, there are 2 water molecules times 18.0153 is going to equal 36.0306. We add these numbers up. The answer actually gives us in the least number of decimal places, so we don't have to round anywhere. And then we're going to do percent composition down here. Okay, mass of the part, this is the water, okay, divided by the whole, this is the whole hydrate, times 100, and that will give us 14.8%. So water by mass is 14.8% of the entire compound. Last but not least, our last practice problem here says which species contains the greatest percent by mass of hydrogen. So we don't really have to do anything here, because first we're going to look at all of our compounds and see which ones have hydrogen, and that would only be this one. So this would be the answer. Okay? Obviously, this is going to have the greatest percent by mass because it's the only compound that has hydrogen in it. All of this would be 0%. 0% hydrogen, 0% hydrogen, 0% hydrogen. Simple. All right. And so that will conclude lesson 2. Now you should try a few on your own. Do all of page 4 in your homework packets and be ready to go over those in class. And also jot down questions, so I know that you've been doing your homework. Okay, guys?